Water is very important for transporting most of the molecules in the body. In order to understand how water acts as a solvent, we need to look at the structure of the water molecule. The electrons spend more time near the oxygen atom, giving it what is known as a partial negative charge. The hydrogen ends have a partial positive charge. A molecule that has a different partial charges is known as a polar molecule. Let's explore that. The polar region of water these regions are attracted to electrical charges in other molecules such as ions. Polar covalent molecules like carbohydrates, proteins, nucleic acids, and ATP are easily dissolved. And it will be demonstrated here in this animation. Basically, water being what we call a universal solvent, because it carries all of these molecules and ions in the body, allows most of them to easily get dissolved. However, we shall see that some of the molecules cannot be dissolved in water. Now let's take a look at why nonpolar molecules do not dissolve in water. The electrons of nonpolar covalent compounds are uniformly distributed. Compounds such as lipids are made up mostly of carbons and hydrogens, and these are considered nonpolar. Let's click on the fatty acid molecule to explore that. Nonpolar lipids have no charge. Lipids are not attracted to water and do not dissolve in it. In fact, if lipids are placed in water, they will rise to the top, remaining separate from water. Now, we do have a very special type of a molecule that combines both polar and nonpolar elements, and these are called phospholipids. The insolubility of lipid in water makes them very important as structures of cell membrane. They will not be dissolved by watery solutions inside of or outside of cell membrane. Phospholipids have nonpolar tails made up of fatty acids. The heads of the molecule is made up of polar or charged phosphate groups. Because the head is polar, it mixes with water. It is hydrophilic or water-loving. The nonpolar lipid end moves away from the water, and it is said to be hydrophobic or water-hating. These properties give a cell membrane a bilayer appearance, with their tails entwined makes a form of a waterproof barrier to the cell membrane. In other words, phospholipid bilayer is a key structure to the waterproofing of cell membranes. And we will study cell membranes in chapter 3.